Okay, good day. We've drilled our holes and our tangs and whatnot, and now we're going to we're cutting the thread on the outside. This is 3/4 inch UNF, United National Fine Thread, 16 teeth per inch. Don't use any other size, okay? That's what works. It's, have you ever cut a thread with a die? This is a big thread. It requires a bit of, muscle power. This is ideally done on a lathe, which is where it would normally be done. But you can do it with these tools. A lot of the problems with this are the amount of effort. If you've got this big a diameter to cut by hand, and you can't hold the things rigidly in the machine, you cut small pieces at a time, then knock the chip off, so that you don't tear the metal. The easiest way to do that is to add more. If you've got a long tool, good on you. Be very careful you don't break the tool, because you can put a lot of leverage on with this much. Okay, 60 millimeters. So keep it up, make it nice and clean, What's the quickest way to do a job? Do it right the first time. Little bits of metal and all sorts of stuff hanging around. 3/4 inch UNF. 3/4 inch UNF is one of the few thread sizes that cuts the true 3/4 inch from the outside diameter of the thread, which is 19.0 something or other millimeters, which is the outside diameter of that tube. You pitch it 16 teeth per inch. Okay, okay. How to use your drill press as a lathe. We want to machine 1/2 millimeter off this tube, the outside diameter. So this is how you use a drill press as a lathe, or how I do anyway. Now the main goal, well, the advantage of a lathe is that it holds the work very firmly, and it holds the tool very firmly. And when you put those two things together with a nice hard bit of steel for the cutting tip, the softer metal has got to cut. Simple as that. So here I have a nice sturdy drill press. It's a 12-speed press. This is quite a sturdy machine, and it's got a nice 16 millimeter chuck in it, and a number 2 Morse taper. But I've got conveniently a piece of 15 millimeter diameter stainless steel, and the inside diameter of this tube is conveniently 15 millimeter. Now I don't throw anything away in my shed. I've always got some sort of junk laying around, and that's why I keep stuff, because it just so happened I'm measuring around with a vernier in the workshop, and voila, I had a piece of 15 millimeter rod with it. It'll fit nicely down the middle of this 15 mil inside diameter tube. So I use that. Now you have to get a bit inventive here. Depends what you got in your shed. First of all, you need a drill press, of course. But as I say, this is something you could do with just an ordinary hand drill, and as long as you can rotate that tube and you can take down the outside diameter with a file, just keep measuring it. It's not super critical here to get it all perfectly even or whatever. It's got to fit inside the nose of the 4JX1 fuel-injector-sleeve in the head, so we've just got to take it down less than 19 millimeters. Now every tool that I've made, I've used 18.5 for the outside dimension of that piece, and it's fitted well, and there's enough slop in there so that if you're a bit out of centre, a bit off, perpendicular when you lower the tool, and the hole still clicks in and locks into the holes for that application. Okay. Anyway, enough gabbling. So you get the point. Drill press. Somehow mount your workpiece so that it spins nice and sturdily, and use a piece of hardened steel that's had a point sharpened on it. This happens to be a lathe tool, and mount this tool nice and sturdily as well. Everything nice and sturdily mounted. Go ahead. So I'll do it. Hang on. Okay. Next step is to put the bolt through, the high tensile bolt through like that. Now we're going to cut off the thread. Okay, so we end up with that. Now, just ensure that, for your own sanity, that you've cut enough of the length of the bolt off, so that when you tighten the shank down, so the shoulder is tight in the thread that's not sticking out here. I'll show you why. Okay, beginning the assembly of the tool. There's our tangs in there, and we've cut these bolts off to the right length, and they're not sticking out there, we hope. And the idea that what I like to do is you can tighten them down so they come against the shoulder of the plain shank of the thread. And you can see that the plain shank of the thread is almost exactly well, it is 1/4 inch. Oops, 6.3. So yeah, the bolts are 1/4 inch. The hole is 1/4 inch, and I've just reamed it out a little bit, which you can do with a drill bit if you haven't got a ream. And so you can see it's a clearance fit, but it's tight. So that's important, because when you're pulling on the thing, when these are locked into the sleeve holes, you want them firmly in those holes so they don't tip over. I mean, really the thread's holding it, but then if you can have the outer tube holding it as well, obviously it's significantly stronger. And of course the way to tell whether the bolt's sticking out or not is to push your locking tang down, and if it won't go in, but it will. There you go. It goes in nicely. So you can see they're together. And of course the next task is to cut these off to length, or roughly, and then we're going to grind them down, and I'll show you how you can do that in an ordinary home workshop bench grinder rather than in some fancy great machine. And be very accurate with it, So as you can see, it's starting to look like a tool now. We're almost done. Okay, well, we've come this far. We got a 150mm bolt. I changed my mind. Instead of using that 5mm stuff, I'm going to use 6mm, well, 1/4 inch high tensile bolt for the torque pin, same as I did last time. I just ground the thread off there and put a pretty little point on, because it makes it easy to push through. Enlarge the hole in the locking tang to 7mm. If that's 6.3, 7mm, that allows a little bit of slot. But the holes in the tangs themselves that remain permanently in the tool are at 6.3 exactly, and that's a nice fit through there, so that you get torque transfer when you've got those locked into the sleeve dogs. That is locked at the same time, otherwise you'll get stretch in the body. it's not a big deal. It just means you're going to have to keep running a drill through there or something as it settles in, you know. I don't know how long that'll take because I haven't used mine over 100 times yet. But here we've got we shortened the bolts, and now we've got these nice bolt heads sticking out here. Well, that's not a lot of good. We can't fit those in the sleeve, can we? So we're going to cut them off and then grind them to shape. So before we do that, we're going to lock them in so they don't rotate at a later time. So how are we going to do that? Well, we're going to weld them in chemically, and we're going to use this stuff here, which is about as close as you can get to welding, believe me. This is Loctite permanent thread lock. You can use any brand, doesn't matter. Some say you could use super glue. Basically it's the same kind of stuff, but this contains a resin and it fills the threads, and so the gap becomes pretty well permanent in there. Just need a drop. That's it. Now this takes about 24 hours to achieve maximum hardness, but we're going to screw that in there gingerly, like that. Okay, now we give it a little tighten. Don't overdo it, you'll strip the thread. Now once that Loctite has set, then if you've ever worked with permanent lock threads, you know there's no way in heaven and earth that's ever going to come out. Now just to check that you haven't over tightened the bolt, just pull your locking tank out and back in again, and that's fine. So we'll just do the other one now, okay? Okay, step one is to get a bit of scrap timber, you know the outside of that is 19 millimeters. So you get a 19mm arbor, spade bit I use. Well, basically, no matter how you do it, you drill a 19mm diameter hole in there, and then you just cut a slot up here. Okay, I use something like pine or cedar, something like that, because it's nice. That's nice and resinous, so it doesn't tend to break here, crack, split, whatever in the timber. Cut a split up there, and I've got a useless little gesture here. I've put a little threaded bolt in here so I can actually tighten that in and out if I want to. It was mainly to spread the thing so that I can fit it properly in here, you know, like that. Okay, now you don't want that tight in there because you're going to have to spin it. Okay, you're getting an idea what goes on here now? This is a jig to hold it in a grinding wheel. Okay, so we put our locking tang in, which is now nice and firm, which is the way we want it. We want it nice and firm on these tips here so that everything's held nice and tight so it doesn't distort during the pulling process. Okay, now here we have a little bench grinder. Ignore all the mess. That's an order. Now we've got a piece of timber here which has simply got a 19mm diameter hole bored through it, and now we've got it set up so that we can rotate it against the grinding wheel. Okay. Okay, well, if you can see this on the video, we've now ground a radius on that side and on that side as well. Can you see that? So we're starting to get down. So it still looks like it's sitting out a bit far to me, but the test is using the measuring instrument. So what's the outside dimension of those dogs, those locking dogs? 22.3. So I need to mention that you only get one shot at this. You grind too far and you've stuffed the whole thing up. You've got to start again. Just a little note of caution. .7. You could probably be close enough, but every tool, no matter what tool I've made so far, I made them 21.5. So we take off that last 0.2 of a millimetre. Okay, so we go the last little grade. So you can actually do a lot by just moving that wheel guard a little. We're working reasonably fine here, but this is the instrument you're really using here. So how do we go? 21.5 there, 21.5 there. And at the widest point possible, 21 point. Well, 5.5. There's no way that I'm going to get better than that. Okay, well, one more thing to do. Well, two more little jobs. On the nose of the tool here, when it goes to fit down into the sleeve and the head, inside the sleeve there are steps, and it tapers down, and just below the holes there is a step. So we need to take off a chamfer on the end of the tool with a grinder all the way around, and which means we'll grind these tangs as well, get everything out of the way, make it look nice and neat. Now we're going to be grinding the front piece of the locking dogs off. You can see that. We'll show you. So if you don't do that, I mean the tool will still work because it's going to be sprung here and these will slip in and out. But because it's a fairly sharp angle there, well 90 degrees of course, and it's hard and steel, it may scratch the inside of the sleeve, and that wouldn't be a good thing. You want to reuse them, don't you? So here's the block we had earlier with a hole in it so that can fit through there, 19mm hole. Reuse everything here, nothing gets wasted. So I've determined that the angle of 15 degrees is about optimum. You can go down to 30, but 30 is the dimension of most of the tools on the cut-off there. But I'm going to come back a bit further at 15 because it leaves more meat at that very point there in the tool. And as you can see, when you're pulling, that's the piece of the tool that takes a lot of the stress, of the pull. Now that's one of the reasons why I've got an additional torsion bar go through here, because it will not only resist turning and all that sort of thing, it'll also mean that the tangs inside are pulling from the top as well as at the bottom. So between those two support points you can take enormous stress. So we're going to mount the block here on this and set it up so that this is sitting the right distance from the wheel, and then we're going to grind a bit off. So I'll do that now. Okay, good. Here we are. Okay, well, we need to open up that gap there a little, because if you think about it, if that gap's 3mm wide and we put a bead of silicone rubber in there and it cures overnight, 24 hours I say on the tube, when it squeezes in they stick out 1.5mm each side. The actual engagement in the sleeves is on the average 1.25mm each side, 2.5mm. So that squeezes in 2.5mm, so when that's actually fully engaged in the sleeve, well, it's fully squashed in as it goes down the body of the tool, perhaps I should say, then the gap compresses from 3mm down to 0.5mm, and that's probably a little too much deformation for rubber to handle. So we'll make the gap a little wider. If we make the gap 4 to 5mm, then it'll only have to deform 50% of its thickness, and that's what we're going to do. So I use a hand file. I suppose if you had the foresight you'd do this before you put the whole thing together, but I actually like the thing being complete until the end, and it's not like this is hard to do. Mild steel. Okay, so hopefully this can focus, and you can see that in there I've filed out 2 grooves. Okay, now apart from sharing with you my dirty shed and workbench, I've got a few little tricks that I've found along the way. You don't want the silicone to go oozing down into the body of the tool, so you get a little bit of material that's less than 3mm wide. 3mm would be good, I guess. And you want something in there to act as a backstop for when you squirt the silicone in, that doesn't stick to it. And there's a lot of things that won't stick to silicone. There's a hell of a lot more that will. Amazingly tenacious stuff. Glad wrap, what you normally wrap your lunches in, it won't stick to this. So I wrap a bit of Glad wrap around there, like that. And don't worry about having it too thick, because they're not overly generous for this stuff. It's remarkably thin. Here we are. It's almost a complete tool. With 24 hours of sitting around staring at space, or in my case having a glass of whiskey, and that is the tool done. So just to recap, we have 19 by 2mm tubing, we have 13 by 3mm 13 by 5mm, sorry, tangs, 13 by 5mm tangs, which have had a chamfer ground on the edge or filed on the edge. File works just as well as the grinding machine, you know. And we come in 2.3mm that way, go down 2.4mm down the side, and take that chamfer off on the 2 tangs. We drill holes through there. I've made that one a 6mm torquing pin. You can use 5. I wouldn't go under 5 considering the stress on the tool. I'll ream that through so that's nice and smooth. This is 3/4 inch UNF thread. UNF. 3/4 inch UNF. The metric sizes, there isn't anything close to it. The other sizes are somewhat like a 1/2 inch BSP, very standard pipe, but it's too coarse and it's a bit too large for this tubing. Right. 3/4 inch UNF. So with that in mind, I kept a UNF thread in those bolts, because UNF has got more threads per inch. United National Fine, it's an American thread size. Thank you. USA. And you get more threads per inch in there. You get 4.5 threads through the 5mm tang for these 1/4 inch high tensile bolts, which have been ground down. Okay, 1/4 inch, 6.3mm if you're looking at metric sizes. If you're in Europe or something, even America now. We've ground that 15 degrees off. You could grind it at a steeper angle of 30 degrees and go half the width of the locking dogs. I'll leave that to you. I prefer 15, give me a little bit more nose here. I haven't run into any sleeves where that was not able to engage fully in the holes because I couldn't push it down far enough, but I don't know that all those Isuzu sleeves are exactly the same. The holes are only drilled in for the sake of having fuel come into the injectors, so they're not critical like in some parts of the engine machine. Now we've used silicone rubber here to provide the spring at the tip of the tool. And in this case I've used just ordinary plum works, what we call it here. Got this from my local hardware store. Antifungal acetic cure silicone sealant. Sealants, by the way, are basically adhesives, and it's got a very strong adhesive action, which you can tell by the smell of acetic acid in it. Right, now if you remember, this is what we're making. Now we've got two, okay? Aren't they pretty? Now, just to remind you of what the locking action is like. So I've got a locking bar there. Take out the locking tang. Take off the 3/4 inch UNF nut. Take off the 1 inch water pipe external sleeve. And this is just my test sleeve, which I'll try that one on tomorrow at 3:30 in the afternoon after it's had 24 hours to cure, and you'll get that, okay? And when you're setting the jaws for doing the extraction, during the extraction, you put your tang in just for the first hole, which you've drilled up to 7mm, okay? And that holds everything nice and parallel and straight, and you've got that kind of spring. Works great. Okay, that's it. You made one. Go ahead and start pulling apart 4JX1 engines now. Go for it. Okay, I won't bore you with the details of this, but this is for the outer sleeve. The only real requirement is the inside diameter of the pipe needs to be big enough to go over the body of the tool. But there is another requirement, that when you get down between the camshafts, you find it's quite tight inside in the head, you know, unless you want to take all the camshafts off. So this size works. I think on the Isuzu Trooper from memory you can go as big as 27mm in the outside diameter. So 27mm, this is 26.5. Now in this country we call this 1 inch water pipe, so it has a wall thickness of a couple millimetres, 2 point something, I don't know what, but it fits over the tube. Now I suppose the only real thing to observe with this particular part of the tool is that the wall thickness doesn't want to be so light if you only find a piece of very light tube, so that when you're putting an enormous amount of force on it with the nut, that it doesn't crush that. And it's 100mm long. Okay, well here we are a day later, and the silicone's quite cured, so the first thing to do is just put a little spacer up and just carefully ease it out. And we'll find that the loud wrap, the lunch wrap, smooth slide out. There we go. Okay. Now if you have a look, can you see there's a gap in there? Okay. So first stage. Okay. So you get a Stanley knife or a carton cutter or whatever you call them, and you just trim the silicone rubber to look nice and neat.